Okay, YouTube, in our last video we discussed the concept of what a logarithm is. In this video we're going to more work with logarithms in terms of evaluating them, distinguishing between a couple of very special logs called the common log and the natural log, and then evaluating a few of those on a calculator and discussing their reasonability in terms of our values here. So let's go ahead and start with our evaluation of logarithmic expressions. What we want to do here is evaluate the following log expressions without the use of a calculator. So essentially, we don't want to use a calculator here. What's going to make this a little bit easier is to kind of rewrite all these logarithmic expressions as exponential expressions. So recall that if you had something that was log base b of y equals x, something like this, then we're basically asking the question, what could I take b to the power of to get y? And to ask this in a different fashion, we say b is our base, and b turned into y by taking it to what power? To the x power. So essentially, when we rewrite this first one up here, we first want to kind of ask ourselves what the base is. And in this case, the base is 3. So we're saying 3 was taken to the power of something. We don't know this power, but we're saying that it turned into 81. So really the question is, what can I take 3 to the power to get 81? Well, 3 to the second power would be 9. I know that 9 times 9 is 81, so like 3 to the second times 3 to the second, that'd be 3 to the fourth. But I think that we get 4 here, and this would be really easy to check on a calculator. We could say 3 to the fourth equals what? And we would discover that, well, of course, 3 to the fourth power is equal to 81. So now let's look at this next one here. We say log base 5 of 0.004. So when you deal with something like this, again, we're going to rewrite this in exponential notation. So we're saying 5 was taken to the power of something, and it turned into 0.004. The one note that I want to make here is that this is a decimal value, and often it is much more convenient to deal with this as a fraction. So in other words, I could say 5 to the what power, and this 0.04, really it is 4 100ths is what this is. So 4 100ths, which reduces to 1/25th. The idea that I have here is this. I'm saying that 5 to the what power turns into 1/25th. Well, what I know is this. 5 to the second would be 25. So if I took 5 to the -2, then I would have 5 to the second, but it's reciprocal, so 1/25th. So this is going to be a -2, and of course we could do this without a calculator, but my recommendation is to rewrite this into exponential notation and then take this decimal and rewrite it as a fraction, a little bit easier to work with. Speaking of fractions, let's look at letter C here. We say, okay, so what's our base? The base here seems to be a half. So if I rewrite this in exponential notation, we're saying I took a half to the power of something, and it looks like it turns into 8. So what could I take a half to the power of to get 8? Well, one thing I can tell you is this. This one's bigger on the top here than it is on the bottom, and this is bigger on the bottom than it is on the top here on the left. So this must be a negative exponent, seeing as how it's going to have to reciprocate itself. The other thing that I want to kind of point out here is this 2 to the third power equals 8, so 1/2 to the negative third power would be the same thing. So we're going to say this is going to be a -3, which basically is going to flip this over and then take it to the third, which gives us our 8 here. So we say this is -3 right here for our logarithm value, or exponent value. And then last but not least, we say 9 to the what power turns into 3. Well, again, 9 to the what turns into 3. The interesting thing here is we're going to have to recall something algebraically, but I would say that the square root of 9 is 3, but that's also 9 to the 1/2 power, where we say that this is 9 to the first, and this is the square root of that, where the 2 is the root and the 1 is the power. So we're going to get a value of a half here, but essentially, we were taking a root of that. In this case, we get log base 9 of 3 is a half square root. So a couple of things really quickly here. We have the common log and the natural log. And what I'm going to say is that we often deal with, when you're talking about exponential things, you deal with things that are like 10 to the power of x, and you also deal with things like e to the power of x. You do these types of things a lot. So if I were to say, well, what could I take 10 to the power of to get a specific value here? I'm going to have to use a log base 10. So we say log with a base of 10. See how these bases are the same here. And this has a name. It is called the common log. Okay, so common log is this log base 10. And what I'm going to tell you about the common log is that we just write log. I mean, it just is this. So when we write the natural log, this would be something where we say log base e. Notice this has the same base as our exponential with our unknown exponent value. But essentially this right here is the same thing as what we're going to call the ln. Okay, so of something here, of course. We can fill that blank space in, but essentially ln, this is the natural log. Natural log. Okay, so log natural, I don't know how you want to remember that, but basically that is what that is right there. So we often use these so much that we look at this. On your calculator, you have a couple of buttons dedicated to them. So you have the natural log and the common log. What you'll find is all these that we looked at up here, log base 3, log base 5, log base 9, whatever, you're not going to have those log buttons on your calculator. We're going to have to learn a change of base formula later to be able to evaluate those. So for right now, ln and log base 10 are both on your calculator, and we're going to use these here to evaluate these up here. So for instance, I'm asking this question, 10 to the what power equals 5? Well, you know what? A little bit easier to think about if we rewrite it this way. And my calculator, in this case, since I have a common log, it's log base 10, what we can do is we could say, well, I'm doing log base 10 of 5. So I'm going to type in my 5 on my calculator. I'm going to hit log base 10. It says 0.699-ish. Okay, so this is 0.699-ish. You know what I want to do? I want to check this. So here's the interesting thing about it. If I said 10 to the power of this, I get 5 exactly. If I say 10 to the power of 0.699, I almost get 5. It's a little bit bigger than 5. And the reason why is because this value is rounded. It was rounded up a little bit, and so I got a value a little bit bigger than 5. So for right now, we're going to say that this is approximately 0.699, and I'll even throw, for good measure on there, I'll throw in an ish. Okay, 0.699-ish. So we're going to finish these other ones out here. So log base 10. Remember I said we could just write just log. And log base e here we could write ln. Well, let's do our log base e of 26. I'm actually just going to do this one here. We say 26 natural log of this. So 3.258. So 3.258. But here's the idea. If we were to have rewritten this, we were saying e to the what power was equal to 26 here. And what I'm saying is that power must be 3.258. And again, I want to check this here. I want to check this. If I took e, let's see, to the power of 3.258, 3.258, I'm going to say e to the power of this. Look, you almost get 26. And the reason why is because I rounded, again, because I rounded. So these last two really quickly here, let's just toss these in. We say ln of 15, we say 15 ln key, 2.708, so 2.708, that's a 7. That's a decimal. And then this log 4, you notice that there's no base listed, so we assume that it's log base 10. So 0.602, 0.602-ish. Okay, and the idea here is that this right here, we don't have to write the common log to know that's it. Just like I don't have to write this to know something's a square root. I don't have to write a 10 down here to know it's a common log, and I don't have to write an e down here to know it's the natural log. But if you want to, as an audience member there, you could say you can always write those, and it's not going to make a darn bit of difference. So, cheers.